Yeah, thank you for coming. Let's start. Okay, that's awesome. Okay, my talk is about modifying struct tags, and the first thing is the question: why do we need tooling? And I'll start with a little small example why we need it. So this is just a struct with a single field, and this is the struct tag, and this is really easy to write yourself manually. Maybe not for the first time, but if it's just one single field, it's easy. But the problem arises when you have many multiple fields. For example, for this struct, and you have to go and write multiple JSON struct tags. And this is not fun, you know? Writing all these fields, all these struct tags is not fun. And then, so we can make it much more easier and simplify it. But first, let's start to define what a struct tag is, and then go from there. And so the first of the thing is, when you open the Golang spec, you'll see that there's no official spec what a struct tag is. But fortunately, there is one, an unofficial spec in the standard library, and it's defined in the reflect package. It's a bird inside the reflect package with the type struct tag. And then this is really like very terse, and it's not easy to read. And that's why I'm going to now start to decompose the spec a little bit so we can understand it better. So let's start with this simple basic struct tag. The first thing is the key. The key is an unquoted string literal. And then comes the value, which is quoted. And between the key and the value, there is a separator, and it's the colon. This is not very specific clarified if you read it. And you can have multiple key pairs. And if you want to have multiple key pairs, you have to use a space between them. And then finally, you have to use backticks. You have to quote the whole thing. So you can add it, append it to the string, to the struct field. You can also use just normal quotes, but this is not fun to work with. So that's why we are using backticks here. And one more thing is, important thing is that the value is quoted, and the value can be anything. But we use something like this omit empty string, which comes after a comma. This is not part of the spec, and it's called option. And many packages, like the encoding JSON package, uses this notion. And so this is not a part of the spec. So if you do a recap, this is the full specification of a struct tag with all the keys, options, and values. And so back to our initial slide, and I said we had here an example with multiple fields. So this has some errors, I lied, it's not correct. So what are these? So one of these is having multiple key pairs, and this is wrong because it needs to be space separated. So one of the errors is that. And this is the second error, and this is also wrong because it's separated with a colon. And here it uses the equal, which is wrong. And this is our third error, which is again wrong because values needs to be quoted, and this is not quoted. And our final error, again, seems like a perfect valid struct tag. It is not, because the key is not quoted. So as you see, in this, just in this one slide, I put just 4 errors, and nobody could detect them, because struct tags, writing struct tag is not easy and not fun. People always do something wrong with it. And so because we are engineers, we are developers, we are trying to automate it, right? It's not fun to deal with. Why not automate it and make it much more easier? And so my first attempt was very simple. So in Vimgo, I had a command, and then it would, like when your cursor is here, it would first search backwards for the struct and the right-hand brace. And then after that, it would do a forward search for the right-hand brace, for the other brace. And then it will select all the lines between the struct, and it would get the first identifier, and then convert it to snake case and append it. So when I introduced this command, Vimgo, it was really great. People started using it, and they said, wow, this is amazing. And then they started open issues to Vimgo, and I said, no, it's not amazing. So it was not fun to deal with the issues. So what were these issues? One of the things is that because I was just appending it, it was not formatted. So people said, hey, this is not formatted, it should be Go formatted. So this was one of the problems. And the other problem was, if there was a comment and no struct tag, it will just append it, because it didn't understand what the comment is. So, but it had to understand it. One other problem was when someone was using the nested struct, again, because it would take the first word, it would append it. It is again wrong, because for a nested struct, it comes after the right brace. And then last example is if there is already a field, because it was just appending it, it was again wrong, because it should be quoted. All the key pairs should be in a single quote. And there were much more other problems with it, like we couldn't remove tags, and then it was not easy to add and remove options. And anything, if the comment, for example, itself has a brace character, it didn't work. So how do we fix it? And so this should be better, and there should be a better solution for this. So I took a step back and rethought how we could fix it. And then there was a second attempt, and also the final one. And let me explain what this attempt is. So we have, when you look more carefully, we have actually two problems here. One of the problems is we need to be able to parse the struct correctly. So we need to be able to read the comments or understand the nested structs. That's one of the problems. And the second problem is we need to be able correctly parse the struct tag, because if I want to add another key pair, like I have already JSON, I want to add XML, I have to parse it. Or if I want to add an option, I again need to parse the struct tag. So first, let's start fixing the parsing the struct. And for this, we are going to use the GopherCon family. So the GopherCon family has multiple packages, and which allows you to parse a valid Go source, and then get the ASD, the syntax tree. It allows you to modify it. And then finally, with the printer or the format package, you can then print it back to a valid Go source. So before I deep dive, let me show a quick tutorial about GoASD and what it means. So here we have a single node. It's called the binary expression, ASD binary expression. And we can further expand this. So the integer can be represented by a basic literal, just the 3. And the other integer, the number 2, can be also represented by the basic literal node. And if you combine it and add an operand, the plus operand, this is the whole tree for this simple expression. Another example, and you see this is now actually 2 expressions. And this 7 minus 5 is another binary expression. So this is just a small example. But what about, for example, this simple struct? First of all, this is a type declaration, and any type declaration is defined by the typespec node. And the struct itself, without the type keyword and the example, the name, is called the struct type. For example, if you write Go test, you don't go and define a, for example, struct. So this is a struct type. It doesn't have a name, for example. If you parse it, and if you print it, it doesn't show the name of the struct. So you have to get this type spec. And then it has another node called the field list, which contains all the fields. Because we have here only one single field, we only have one node. And then this node further expands. It has a slice of identifiers, because in a field you can have multiple names. And another node is for the type of the field. And lastly, another node is what defines the struct tag. So this is the important node that we are going to use to change and rewrite it. And so finally, this is the whole tree when we go and parse it. And any node in the tree is actually an interface. So when you get any node, you can immediately know when it starts and when it ends in a file. And this is going to be really useful further when we're going to implement the tool itself. And so how does it look like when we try to write it? So first of all, here we have a really small, again, example, the same struct. I define it and assign it to the source variable. And then I use the parser package, and it has multiple, it can parse directories, it can parse packages. This just parses the file. And then it returns me the tree itself, which is the file variable. That's the tree itself. And further, now that I have the tree, I have to walk the tree and find anything. So because it's really hard just to do type assertion and looking for all the fields inside the structs, we can use the inspect function in the ASD package. So you pass the node, and you also pass a function literal. And then this function, the inspect function, calls this literal for each of the nodes it visited. For example, I'm here I'm looking if the node is of type struct type. If it's not, I return true. And this means, hey, I'm still looking further. Please go and walk the tree. If I return false, it immediately stops walking the tree. Once I have the struct type, I iterate over the fields. I get the field name, because I have only one field. The first index is just a 0. And then I also get the tag, and then I print them. So when you print them, you just get what you parse it. This is really a really example, and if you copy and paste this, it just works. You don't need to do anything else. So this is how we parse a source file, a Go source file, and get the ASD. The second thing is, how do we parse the struct tag? So we can parse this Go source file with the parser package, but how do we parse the tag itself? So remember this, and so for example, when you do the spec or the C package, there are no notions of the struct tag. But packages like encoding JSON, for example, they can understand the tag. And then you think, how do they parse it? I mean, and so for that, I said that there is an unofficial spec in the reflect package, the struct tag. If you create a new type and using the struct tag, that type also has a method called get. And when you call it, it will go and get the value and print it. So when you define a new type and call this method, it will also parse the struct tag. And then you say, wow, okay, this is nice. I mean, I can parse the struct tag. But it's not perfect. It has some quirks. So what are these? So if your tag is malformed, you don't have any idea what's wrong. As I said, it might be quoted, there might be a space separated between the keepers, there must be a space, and many other problems, like you can't go and parse the option itself as well. So because of these problems, we can't go and use the struct tag. So we need to improve it, and how do we improve it? We go and write a new package for that. So I wrote a package called struct tag, and which has many methods to deal just with this. And then, so what can we do with it? So let's start with this example. Here I use the parse function of this new package, and then I get all the tag, all the key pairs, and I can iterate over them and just print them. And then here you see I printed the JSON key pair and the XML key pair. Once I have the tags, I also can get just one single key pair. And then it also supports pretty printing. Like if I just print the key pair, it just prints the whole struct tag. But I can also get the key itself, I can get the value itself, I can even get the options itself, which is really nice. And how we change it, here, for example, I again parse it, I get the JSON tag, I replace the name, so the value with bar, and I remove the options. And if I set it and print it again, it's now JSON bar. It totally has changed. We can go and also add a new tag here. For example, I add a new key pair with the HCL for the HCL key with the value gopher, and I also add a new options. It also allows us to add and remove options. Here, for example, in this example, the JSON key pair, it has the full value, but it doesn't have any options. So I add omit empty to it. And I also can delete options, and from the XML key pair, I remove the comment. And when I print it, it just prints as it like in the modified version. So by using the Go parser and this new struct tag package, we could fix both of these problems, which is really nice. So now that we have these correct tools, let's go and start implementing the CLI itself. I wrote a tool called Go Modify Tags, and you can call this from the terminal or from your editor itself. But how is this written? So let us explore it. So this is first, you can just go get it and start using it. And then this is the main part of the tool itself. And when you download the tool and look into the main function, you'll see the exact same functions. I mean, I just simplified the error parts, but it's the same thing. And what does these things mean? Let us go over it. Like, let us start with fetching the configuration settings. So we need some kind of configuration to dictate what we do. We need to tell the tool what and how to change the tags. And the CLI tool, the Go Modify Tags, it just uses the flag package. And then for each of the configurations, I just created a new flag, and then you can just use it. But what things do we need exactly? So we need, these are the configuration, and let's start with the content file. So first of all, of course, we need the file itself. You can define it, but you can also define from just standard input. Like you can just pass the buffer from your editor without saving the file if you want it. And then next, and where and what do we output and how do we output it? So this tool by default outputs to standard output. That's why you can't change it unless there is a PR that needs these features. But right now, there's no features. However, you can define if you want in JSON, like in a custom JSON format, or if you want it in as a Go source file. And there is also a Boolean called write, where you can override it if you want the file directly instead of outputting it. And then we also need a way to find which structs we want to modify. And then there are a couple of things. I'm going to explain them in a bit. And then finally, we need to tell the tool what tags we need to modify, or what key pairs we want to remove. If you want to override it, the transform, like you can use snake case, you can use camel case. There are many other options. And then you can sort them, you can add options, and many more. So, so suppose we have this single file here, and then I call with these three flags. I pass the file, I say I want to parse the example struct, and I want to add the tag JSON. So suppose this black box is the tool itself. So we're going to start by parsing the content. This is the first step. And then let's talk about this. This is actually the most simplest part because of the Go parser package. And it just parses and returns it. And it uses the Go parser package, as I said. And then it returns the node, and which is the tree itself. And that's it. That's the most simple parse. And after that, we are going to switch to the second part, which is the find or the lookup part. So this is a more interesting part because we need it. So finding is an important part of the CLI because you might have multiple structs and you might want to only change one of them. So that's why we need a start and the ending position of the struct you want to change. And suppose this is our node, this is our file, and this is our AST3. We need the struct that matches our criteria. So there are many ways to find the struct, and so let's go over them. And suppose we have this simple example file, and I want to change this struct, the server struct. The first of the thing is you can just use the name server. So you can traverse the AST and then look for the name server. And then once you have it, you can get the start and the ending line. And remember that each node, AST node, was an interface, and it has a starting and ending position. So that's why this is very important. So now, because you have the AST, you can easily get the starting and ending position. This is one mode. The second mode is the offset mode. And so if you use an editor, this is really useful because your cursor is actually a file byte offset. So here, for example, in total, there are 163 bytes, and your cursor is on the 96. So I can, again, traverse the tree, and when I see that the offset is between the braces, I can just say, okay, give me the start and the end lines. And the third mode is just passing the lines, 8 and 10. And for example, how is this useful? Suppose in your editor, you just select the lines, and that's it. I mean, you give the tool the lines itself instead of giving what he should look for. Or for example, here, it just selects one single line, and which means that the starting and the ending line is the same number. So we have to select the struct that matches our criteria, which then returns the starting and the ending lines. So this was the find part, and now we are going to move to the third part, which is the modify part. This is where the fun is. So in this part, we have the node itself, and then we have the starting and ending position. Now we have all the information we need, and also from the configuration, we have the flags. The user already passed it, and we can now just go and find the struct with the starting and ending position, and then rename it. So let's start. So we have the starting and ending end line positions, and this is the node we parsed already, and then this is the struct we are going to modify. And then let's deep dive into this struct type. And so this has a field list, as you remember, right? And this field list has many, many fields. If you have multiple fields, this will also have multiple fields. So one of the fields has also these nodes, as you remember, like the names, the type of the field, and the tag itself. For example, if I have this simple example, the struct example, this means the names is foo, the type is string, and the tag is JSON foo. So if you want to rewrite it again, we just going to select the tag node, and then remove it, and then replace it by JSON bar. And when you do it, the file itself, because the node is already updated, is also updated, right? And I'm going to explain how you print it back, but just this is how you do it. And then I showed you a code already, how you parse it. inside the inspect, after finding a field, you just replace it. Like, this is what we do, and this works. Like, if you go and paste it in a simple main file, it will work. So this is how you rewrite it. And so let me show you another example. And this is, again, just with a single field. And this time, it doesn't have any tag. I want to add a tag. So I'm going to use something different this time. I'm just not going to change it and replace it. I'm going to use a function called process. And this process function will go and get the name, the field name. It will transform it to string case, and print it with the struct tag, and then replace it. And so that's how you actually rewrite the tag itself. And inside the source code, remember previously I was just replacing it with a string literal. And this time I'm just calling another function. And this function calls all the methods in the struct tag package, which is able to parse a struct tag, add tags, remove tags, and many other things. So this is the core of the tool itself. So an overview again. So we select the start and ending lines we're interested in, and then we rewrite them by using the process function and the struct tag package. So this is the modification part. Now let's continue with the last part. Just get some water. Sorry. So this is about formatting. And now that we have changed the node, we need to output it, right? So we have the rev-written node, and we're gonna get the string, the source file, and then just print it to standard output. Let's dive into it. We have this modified node, and then we are gonna use this the Go format package. So whenever you use Go imports or the Go format package, when you hit save and it calls, it actually uses this package under the hood. So you can go and write your own Go import or Go format if you like. Like if you don't want to use tabs, joke. Don't do it. But yeah, you can do it. So, and then it just outputs the modified tag itself. It's valid Go source file. We also have custom JSON support. So this is very useful, especially for editors, because editors, they don't want to just replace the file itself, because they have the ability just to replace certain lines. Because otherwise, when you just replace the file itself, the whole content, you lose the history of the file and many other settings that the editor needed. So this is just for the, this is the JSON output is just for editors. So, and why do we output it to standard output? Because by default, I don't change your file, it means dry run, and it doesn't change, it's not breaking anything. And then you get an immediate feedback, you see what's going on there. And then other tools can redirect the output, and it's composable because of that. And that's why there is no options to change this output. Yeah, for testing, I'm just remembering how do I test it. Okay, yeah, I just tested functions, not the standard. Okay, so yeah, so this was the formatting part. And now, let me give you again an overview. This is our tool. We have this simple file, and then we pass the configuration. With this configuration, I start to parse the file. And then I walk the tree, and I find the start and end position. I then start to modify the node itself with the flag configurations. And finally, I use the format package and then output it. So this is the whole tool and how it works. And now let me show you a demo, how that all works. I hope this works. Actually, okay, wait a second. I have to move this to another. Okay, this is more, okay, great. I have to look here, awesome. Okay, yes, okay, great. Okay, great. So I have to look here, sorry. So this is an example file. So okay, this is the editor Vim, if you don't know it, the best in the world. If you call, there is a command called go add tags. So this is just an interface, and when you call this command, the offset mode is being used because you use just the cursor, and then it uses the go modify tags. It shells it out with all the tags, and then it goes and calls the tool, and then it returns a JSON output, and I replace all the lines with it. So this is just a simple add, and you can also like. Okay, thank you, thank you. And you can also like add another tag. Like I can go and add an XML tag, for example. And here, as you see, I have used the line selection. This time, I just directly selected the line instead of giving the struct name or the offset, which is really nice. And for example, I can go and also add options. Like for example, for the JSON tag, I can go and add, for example, omit empty here. And there is also another command called go remove tags. And if you just call it without doing anything, it goes and removes all the tags. And if you want to clear it, for example. But I just undo it. You can also go and, for example, just remove these, for example. You can also, for example, go and remove all XML tags because nobody uses it anymore. And then you can go and use, for example, ACL because it's better. Okay, like this, for example. All right. So you can do a lot of things here. And then there is also, and wait a second. Okay. There is also, let me clean this up. Like these examples are all snake case. And then, for example, in Vim, because Vim's UI is really like you have always write it down, all the settings. For example, if I say, hey, I wanna use, for example, okay, I hope this is correct. I wanna use camel case instead of snake case. Okay, now this is set. And when I call go add tags, and now this uses now camel case, as you see here. For example, this case is camel case. So it's up to the editor how it implements and how to fetch the configuration and passes to go modify tags CLI. So this is how it works. And all right, now, okay. Let me start this again. Okay. So this tool was built from ground up for editors because nobody goes and uses this from the CLI. And that's why it has the mode offset and the range of lines directly. And you can write to the standard output, or you can overwrite the file itself if you wanted. It has custom JSON output, and it has support for unsaved buffers. If you need it, it's more advanced. And then it has individual CLI flags for all the features you need. And the supported editors are Vim, because I wrote this and I also had to edit to Vim. And then we have Atom and VS Code. I want to thank for Zach and Ramya. Is Ramya here? Okay, Ramya is there. And Zach, can you stand up? Can you stand up? Zach, okay, just applause them all. Okay, yeah, thank you. Yeah, so Emacs, yeah. I don't want to say much. It's still VIP, work in progress. So you have to do some pressure if you want to have some Emacs feature support. So once I've released this tool and added it to Vim, Vimgo, and then suddenly all the bugs and issues that we had, we fixed them all. And immediately I just closed them, and it was really wonderful. It felt really great. And so for a recap, we have a single tool and which is capable to be able to call with inside multiple editors. It's easy to maintain because it uses Go, and it uses Go parser, and then the Struct tag package, it has tests. And it doesn't have any bugs because the Go parser is already used by millions of other people, or Russ said 500,000 or whatever. So I mean, if there is a bug already, there's probably someone who already fixes it. So I don't deal with it anymore. And then finally, in the end, we have many happy and productive users. And this, ladies and gentlemen, is, I think, what matters in the end. You know, you're productive and you're happy. So thanks. Yeah.
All right, keep it going for Fatih.